minutes in the second session. So actually, I shared one link with you. As of now, don't try. I will let you know when you can start. Still, something is there. I have to convey. I want to tell. So later you can use that link. Fine. So coming to the second session for today. So we discussed that uh, the machine learning algorithms are classified into two categories. One is called uh, supervised learning. Another is called unsupervised learning. So the basic difference is in supervised learning, we feed the data which contains both input features and output variable to the machine learning model to learn. Whereas in case of the unsupervised learning, we feed only input data, input features, no output label or output variable. Hope you understand. Okay. Now, coming to these are the different algorithms. So coming to the different type of problems we will discuss now. So there are many problems, real-time problems that can be solved by using the AI, artificial intelligence. Now, how we classify, how we divide this type of problems we were going to discuss now. Okay, so try to concentrate well. So try to understand. It will be helpful. It will be helpful more to clear the examination and also to go further in depth of the AI and machine learning in future if you want. Now coming to the problems, real-time problems that can be solved using the AI, machine learning or deep learning are generally classified into three categories. Generally classified into three categories. So, so what are the three categories? So the real-time problems that can be addressed by using the machine learning or AI or deep learning can be solved, can be classified into three categories. One is called as the regression problem. Another is called as the classification problem. And third one is called as the clustering problem. So any problem in the real time that can be solved using AI comes under any one of them. Here we have three problems. It will come under any one of the problem. It may be a regression problem, it may be a classification problem, or it may be a clustering problem. So what is the difference between the all these things we are going to discuss now. Now, coming to the regression problem means, suppose if you are working on one prediction problem, if you are working on one prediction problem, in this prediction problem, you are going to predict or forecast a particular variable. You're going to predict or forecast a particular variable. Then, and that variable is a continuous number. The variable what we are going to predict, the variable what you are going to forecast using AI model. That variable is a continuous variable. So continuous variable means it may be a 30, it may be a 40, it may be a 50 or 35, 32.5, 40.5, 45.5, 40.75, any number, it's a continuous number. So such type of problems are called as the regression problem. Such type of problems are called as a regression problem. For example, I want to build one machine learning model or AI model. I want to build one machine learning model or AI model to forecast the temperature in SR University. To forecast the temperature or to predict the temperature in the SR University. Then that type of problems comes under the regression problem. Why? The variable what I am going to predict, the variable what I am going to forecast. So that variable that is called temperature, it is a continuous number. Your temperature may be a 27 degrees centigrade, or maybe 28 degrees centigrade, or 30.5 degrees centigrade, or 42 centigrade, or 43 centigrade, whatever it may be. It's a continuous number, any number. So such type of problems are called as the regression problems. Okay. Now coming to the classification. So coming to the classification problems are further divided into two categories. One is called as the binary classification, another is called as the categorical classification or multiple classification. Categorical classification or multiple classification. So what is the binary classification and what is the categorical classification? Okay. So I want to give the example. That is, suppose if you want to build one application, so that application will ask a few parameters, like it will ask what is the fever, what is the oxygen level, and whether you have the cold or not, whether you have the cough or not. Once you click on the submit button, then it will give the information about whether the person has a COVID or not, whether the person has a COVID or not. So such type of problems are called the binary classification. Binary means if he is a COVID positive, you will get 1. If he is a COVID negative, he got 0. Either 0 or 1, whether the positive or negative. After feeding this information, so these 4 values are called the input features. So based on these input features, based on these input variables, your application, your model will predict whether the person has a COVID or not, will diagnose whether the person has a COVID or not. So your output variable values will be either 1 or 0 in case of the binary classification. Where in the categorical classification, that value will be continuous number, any number. But where in the binary classification problem, you have the output variable value either 0 or 1, either positive or negative, whether yes or no. So that type of problems are called as the binary classification problem. And coming to the categorical classification problem. So in the categorical classification problem, that is not there is nothing but the multiple classification problem. Here you have the only either yes or no, but here we have the multiple classes. Multiple classes. So means the application what we are working. Suppose if you want to build some mobile application, you want to develop an AI model. You want to build one mobile application and you want to build one AI model. Okay. Someone is in the lobby, so just a minute. Yeah. So, uh, so, so I hope I know categorical classification, right? So suppose you are working on building a AI model which is able to recognize the Indian currency notes. You want to build a AI model to recognize the Indian currency notes. Then what you have to do? You have to take the multiple images. Like you have to take the a 10 rupee image. You have to tell it the 10 rupee. You have to take one 20 rupee image. You have to tell it's the 20 rupee. You have to take one 100 rupee note. You have to give it the 100 rupee note. So like that you have the multiple classes. So your image may be a 10 rupee class. Your image may be a 20 rupee class. Your image may be a 50 rupee. Your image may be 100 rupee. Your image may be a 200 rupee or 500 rupee or 2000 rupee. So that's a multiple classification problem, right? Because you have the multiple possibilities. It may be a 10 rupee or 2000 rupee or 200 rupee or 50 rupee or 100 rupee or 500 rupee. So there's a multiple classes, any image. So output variable will be any, either of 10 or 20 or 30 or 100 or 500. There is no 501. There is no 502. So don't go into the regression problem. It may be multiple classes. It may be a 10 rupee class. It may be a 20 rupee class. It may be a 100 rupee class. So if that is the problem, your output variable has a distinct value, discrete value, but more than 2. Your output variable has a discrete value, either 1 or 2 or 3, like that. But that is more than 2. Here we have the only 2 discrete values, 0 and 1. But where in case of the different discrete values, 10 rupee or 20 rupee, 50 rupee, 100 rupee, 200 rupee, 500 rupee, 1000 rupee, like that, discrete values. So different classes. Then it's called as a categorical classification problem or multiple classification problem. So these are different type of problems I'm discussing. And last one is a clustering problem. So clustering problem is, so you have the unlabeled data, but you think that there is some similarities between the different data points, and you want to group the data into multiple groups. You want to separate the data into the multiple clusters. So then that type of problem is called as a clustering problem. The example what I said in the before session, first session. That means machine learning engineer entering into the substation operator and ask the data. And substation engineer said that I have the hourly load data, but don't have the data related to the whether it is a weekend or weekday. Then he take the data and later it grouped into two clusters. So such type of problems are called as a clustering problem. So that means you have the data points and group into different categories, different clusters. That is called as a clustering problem. Okay. So hope you understand the difference between the regression problem, classification problem, and clustering problem. So I want to ask a few questions. So if you're able to understand this scenario, please respond positively. Let's assume I want to work on a load forecasting problem. So based on the last 4 hours load data, based on the last 4 hours price data, based on whether that day, when at what time I'm going to predict the load, the day is a weekday or weekend, and the season is a winter, rainy or summer. So based on these input features, I will write the scenario here. Then only you are able to understand. So I want to work on some. 1 minute, please. Yeah, sorry. Okay. So let us assume I want to work in the work on a regression. I want to work on a problem, load forecasting problem. So I want to build one machine learning model. That model will take the will help to predict the load at a particular time of the day. That I want to build some machine learning model which is able to predict the load at a particular time t based on the few features like last 1 hour data and 2 hours before data and 1 day before data and 2 day before data. Based on these input features, I am trying to forecast the load L of t on a particular substation or particular energy market. Okay, if that is the scenario, then tell me whether it comes under the regression problem or classification problem or clustering problem. Anyone, please? Which type of problem it is? Please respond whether it is an example for the regression problem or it is an example for the classification problem or it is an example for the clustering problem. So similar type of questions will come in the examination. That's why I am asking. So whether you are able to understand or not. So the problem is I'm trying to forecast or predict the load on a substation based on the last 4 hours load data, based on last 2 hours load data and last 2 days load data. Let us assume. So example, I'm trying to forecast the load today at 4 p.m. based on the load available at the 3 p.m. today and 2 p.m. today and yesterday 4 p.m. and day before yesterday 4 p.m. If that is the my approach, I'm trying to forecast at 4 p.m. today. So this is the example for regression problem or classification problem or clustering problem. That's what I'm asking. So Tata Rohini, you are right. So it is a regression problem. Why it is a regression problem? Because what variable I am going to predict? What variable I'm trying to forecast? Anyone please? So what variable I'm trying to forecast? In a load, right? Huh? So good, Hakim, thank you. So we are going to predict the load. So your load may be any value. It may be 2000 kilowatt or 2300 kilowatt, 2500 kilowatt, 3000 kilowatt, 3500 kilowatt, 3262 kilowatt. So any value. The what we are going to predict, that is a continuous variable. So it is an example for the regression problem. So clearly understand, huh? Because this type of questions will come. You don't need to implement, you need to write anything. Just try to understand the question, you have to choose the proper option. So your load is a continuous variable. So you are going to predict the load. So it is an example for the uh, regression problem. I think you understand, right? Done. Now, second question I want to ask. So as a machine learning engineer, I entering into substation. I ask the operator, give the hourly load data, and against that hourly load data mention whether it's a weekend or weekday. He gave the data. He gave the data. He gave the complete 5 hours load data every day, 24 hours, whether that day is a weekend or weekday. He gave the data. Now with that data, I want to build an AI model. With that data, I want to build a AI model. That AI model will take this 24 hours load data. It is able to predict whether the data is load data is corresponding to the weekday or weekend. Where that load data is corresponding to the weekday or weekend, that AI model will give us output. Now tell me, this problem is example for the regression problem or classification problem? Yes, Hakim, you are right. Yeah, 96, right? Dharani, right. Perfect. So all the peoples are able to give the right answer. So this is the example for the perfect classification, because your output variable has only two choices, two classes, whether it is a weekday or weekend. So it is a two choices. Now tell me, I agree it is a classification problem. Now tell me whether it is a binary classification or categorical classification. Tell me whether it is a binary classification or categorical classification. Yes, it is a binary classification because we have the only two classes, whether weekday or weekend. That's it. So it's the example for the binary class. Such type of questions only it will come in the examination. Okay. Now, um, so let's assume you want to build a AI model to predict. So you want to collect the data, voltage data and current data from the grid, from the network. And based on the voltage data and current data at the various buses and the lines, and you are able to identify whether there is any fault happening in the grid or not. Based on that measuring sensor data, based on the data collected from the various measuring devices, voltage measurements and current measurements, your AI model able to detect, identify whether there may be any fault in the whole network or everything right, no fault, healthy. If this is a problem, tell me it's a regression problem or classification problem or clustering problem. Assume you have a data. That means if this is the voltage at the bus 1, this is the voltage at the bus 2, this is the voltage at the bus 3, this is the current at the line 1, this is the current at line 2, this is the current at line 3. Then if this is the case, these are the healthy conditions. And if this is the something like that, some other data is coming, then it is an unhealthy condition like that. So this example is a classification problem or clustering problem. Rohini, you are right. Dhanush, right. So it is example for the classification problem. Now again, the classification is a binary classification or categorical classification. Your AI model will tell whether the network is a healthy or fault low, if there is any fault or healthy system. So now it's a yes, it is a binary classification, Hakim, right? It's a binary classification because I am focusing on whether the network is healthy or not, whether the network is a no fault condition or in the faulty condition I am observing. So it's the example for the classification problem and binary classification. Very good, very good. Now I want to change the question slightly. That is, so I have to collect the data from the various measuring devices of the network. And from the data, I have to identify which type of fault existing in the network, whether it is the LG fault, whether it is the LL fault, whether it is the LLG fault, whether it is the triple LG fault. So I'm trying to identify which type of fault will be happening in the grid based on the collected data. So I have to build a AI model. That AI model will give the we will give the voltage and current information at every bus and line to this AI model. And your AI model will give the information about whether there exists L fault, LLG fault, or LL fault, or LLG fault, or triple LG fault, which type of fault is existing there. That information your AI model will predict and give, will diagnose and give. Now tell me, this is an example for what? Regression or classification? Classification, right, right, right. All are good. So it is the example for the multiple classification or categorical classification problem. The example for the classification, right? Good, very good. thank you for your prompt response. So it will create some interest. So that I can give more information, more case studies. Thank you. Now, clustering, I think you are clear because in the just morning I told. So machine learning engineer asked the data to the operator, but operator forget to enter the week and weekday data. But still machine learning engineer take the data and apply the unsupervised learning algorithm to group the data into two categories. So it's a clustering problem. So that's the example for the clustering problem. That means if we don't have any labeled data and we are feeding that unlabeled data to the machine learning model and the machine learning model divided into multiple groups. So that is the example for the clustering problems. Okay, good. So thank you. Now we will move to the another topic. So we'll continue. One more thing I want to tell. Hope this whiteboard is visible to you all. Just a minute, please. So initially I said that we need to understand the problem and we have to identify which type of problem it is, whether it is a regression problem, whether it is a regression problem or it is a classification problem. That means whether it's a binary classification problem or categorical classification problem, or you have to identify whether it is a clustering problem. Okay, suppose if it is a regression problem, there is a multiple machine learning models are available to attempt this regression problem. That means if you are working with the temperature prediction, if you are working on the load prediction, if you are working on the price prediction, so such type of problems you are working, these are comes under the regression problem. To solve the regression problem, you have to choose the appropriate machine learning model. So before going for the break, I asked one question. So what are the different steps of the machine learning project? All the people give the good response. That is, first you have to understand the problem, prepare the data, label the data, reprocess the data, later choose the proper machine learning model. But which model you have to choose? That's important. So that means if you want to know which model you have to choose, you have to know uh, you have to identify which type of problem it is. Once you identify the problem, then you can choose a proper machine learning model or regression problem machine learning or deep learning model. Yeah. So if it is a regression problem, sorry, 1 minute. If it is a regression problem, we have the different machine learning models like linear regression model. You can solve the regression problem using the linear regression model, or you can solve using the descent tree, or you can solve using the support vector machines, or you can solve using the random forest, or you can solve using the ANN, or you can solve using the sometimes CN also can be used. Even though CN is used for the image process, but you can use the regression problem also, data related problems also. And advanced cases, you can go for the sequence models like LSTM, recurrent neural network model, and you may go with the GRU model like that. So these are the different models that can be used to solve the regression problems. And coming to the binary classification problem, you may go with this is the linear regression model. Now binary regression problem can be go with the logistic regression model. So you use the logistic regression model to solve the binary classification problem. You can use the descent tree. You can use the descent tree for the regression classification also. You can use the random forest for the regression classification also. You can use the SVM for both regression and classification also. You can use ANN for the regression classification also. Okay, you can use CNN also. You can use CNN also for the regression or classification problem. So can choose any of the proper machine learning model to solve these problems. Similarly, categorical classification also, you may go with the random forest, you may go with the descent tree, you may go with ANN, you may go with SVM. So these are the different models that can be used, few models that can be used to solve the categorical classification problem. Whereas clustering problem, generally we will use the clustering problem. We will use the K-means clustering algorithm. K-means clustering algorithm model or K-means model are used for the clustering problems. So these are the different machine learning models that can be used for the different type of problems. So you have to remember that. Linear regression model is used for the only linear regression problems only. And the logistic regression model is used for the classification problems. And descent tree, random forest, SVM, and ANN can be used either for the regression problem or the classification problem. Okay, and for the clustering problem, you can use the ANN or you can use the K-means clustering algorithm also. You can use the K-means or you can use the ANN to solve the clustering problems. Okay? So these things you have to remember. You don't need to implement. So this is a fundamental course. You don't need to implement what the random forest, what the mathematics behind it, how you code it, how you deploy it. That you are going to learn step by step later if you got opportunity. But as part of the A900 model, just try to understand. So what type of problems we have, which type of models are useful for which type of problems, that only sufficient. Okay, hope you understand. Now I want to ask one question, friends. So based on our discussion till now, I said that machine learning algorithms are the two types. One is called as the supervised learning, and another is called as the unsupervised learning. Okay, now another is called as unsupervised learning. Okay, now tell me, and we discussed the different type of problems: regression problem, classification problem, and clustering problem. Now tell me, under the supervised learning, which problems can be addressed using supervised learning algorithm? Which problems can be addressed? And using unsupervised learning algorithm, which type of problems can be addressed? So please respond. Anyone? Oh, okay, sorry. Maybe I didn't open the chat box. Yes, yes. Pooja, right. You said that clustering for the unsupervised problems. Very good. That means clustering problem using unsupervised algorithm. Right. Regression and classification problem using supervised learning. Hakim, very good. That's it. So regression and classification problems can be addressed by using the supervised learning. And as Pooja said, clustering algorithm can be sorry. As Pooja said, clustering algorithms can be addressed by unsupervised learning. As Hakim said, the regression problem and the classification problem can be addressed by supervised learning. Right. So regression problem, classification problem by supervised learning, and clustering problem by using the unsupervised learning. So that type of similar fundamental knowledge you have to know before going in depth of the any course, A or machine learning course, any course. Hope. Very good. Thank you very much. Good. Now we will move to the next task. What this one? So all the things we discussed already. So real-time problems are classified into regression, classification, and clustering. Regression problems like simple linear regression, multiple linear regression, and polynomial regression. So where we can use. So if we are going to predict a continuous value, if you want to going to predict the continuous value, then it comes under the regression problem. And these linear regression models are very simple to understand and implement. And the linear regression models are very simple in mathematics. And the linear regression model takes a very small time, very lower time, and compared to the other models, very simple model. But linear regression model, if you want to use the linear regression model or multiple linear regression model or polynomial regression model to solve the regression problem, can't perform well on the complex problems, real-time problems. So then you will go for the some complex models like neural networks. But simple linear regression model, multiple linear regression model, polynomial regression model, it will perform up to some level. It is easy and easy mathematics, easy to implement also, but it will not perform well on the complex problem. Then we go for the neural networks. Very perfect. Nice. So, sir, you said that for a regression problem, we can use a linear regression model. For a regression problem, we can use the descent tree. For regression problem, we can use the SVM. For regression problem, we can use the random forest. For regression problem, we can use the ANN. You said all those things, sir. Then what I can do? Which one I can take? If you are working on the if really working on any problem, you have to take all the models which can be used for the regression problem. You have to take regression model, you take random forest, you take SVM, you take descent tree, you take ANN. You try with all the models. Then how, sir? Whether I need to deploy all the models in the edge device? No. You try with all the devices, all the models. Sorry. So what I want to tell you is, sir, మీరు చెప్పారు కదా, you said that um, uh, regression problem can be addressed by using the um, linear regression model, descent tree, SVM, and random forest, ANN, RNN, LSTM, GRU. Then which model I can take? So my suggestion is, maybe maybe your supervisor or somewhere you are working, whatever it may be. If you have to work on any regression problem, you can try first to collect the data, pre-process data. You think the data is perfectly all right. Then try with linear regression model, try with SVM, try with descent tree, try with random forest, try with ANN. Maximum possible you can try with all. Then you have a doubt. So if I try with all, do I need to deploy all the models on the edge device? No, I'm not saying like that. Now you have to compare. So you have to compare all the models and which model performing better. You can use that model to deploy on the edge device. To deploy on the edge device, you can do. And moreover, sometimes even though if you try with a single model, there is some parameters inside the model you have to tune it. Mean, so when I'm developing this mobile application using the CNN model, so I'm using the only CNN model. But there are different parameters inside the CNN model. We have to tune it one. So I'm tuning the different parameters inside the CNN model and observe the performance of the model on the different parameters, and which performance is good, I deploy that model in the mobile phone. But I tried with all combinations and compared, and which is the best one I deployed in the mobile. Similarly, you also try with all the machine learning models. For every model, again, you have to try with tune the different hyperparameters, different parameters among all possible combinations, which give the better performance. You can deploy that model on the edge device. Okay. Now you have one question. Sir, you give one statement that which performs well. How? How we know which model performs well? Based on what we will decide. Then there is called as metrics. Error metrics center. So there is a metrics or error metrics. There's some error metrics or metrics are available. So based on those error metrics, we will compare different models. We will analyze the performance of the model. And if you feel the performance of the model are good in terms of the errors, then deploy that model into the final product as a real-time product on the edge devices. Okay. Now, what are the metrics? What are the errors? Now we are going to discuss now. Okay. Now, okay. So what are the errors? So there's a different errors, different metrics to analyze the performance of the various models on the regression problem. So those metrics are called MAE. That is called don't. MAE. That is called as the mean square error. And one more error is called MSE, mean square error. It's the mean absolute error. This is the mean square error. And there one more error called RMSE, root mean square error. And one more parameter is called as the R square value. So these are different metrics that generally are used to observe the or analyze the performance of the machine learning model while solving the regression problem. While solving the regression problem, you have to remember all those things. Different terms you have to remember. When we can use these error metrics, the problem should be a regression problem. Then only we can use these metrics to analyze the performance of the machine learning model. Okay, done. So let us assume, for example, same problem I want to consider what we discussed earlier. Let us assume I want to predict the load on a substation at particular day, particular time, based on the previous hour data and based on the 2 hours before data. Like let us assume, let us assume I want when the load is at 9 a.m. is 2 megawatt and 10 a.m. is 3 megawatt and then 11 a.m. equal to 4 megawatt. Okay, when 10 a.m. is a 3 megawatt and 11 a.m. is a 4 megawatt and 12 p.m. is a 5 megawatt and 11 a.m. is a 4 megawatt, 12 p.m. is a 5 megawatt and 1 p.m. is a 6 megawatt. Like that you have the data. Okay. So these are the output variable values. Actual output variable values are these. Now you give this data to your some machine learning model. That may be a regression model, that may be a descent tree, whatever it may be. Now train the model. After training the model, now feed the input data to the same model. Take you consider one linear regression model. And this linear regression model trying to predict the output L of t based on the inputs 1 hour before load data and 2 hours before load data. So based on this data, you train the model. Okay. Now, so now what happened is after training, now feed this data, input data 2 and 3 to the LR model and note down what is the predicted value LP of t, what the machine learning model is predicting. What the machine learning model is predicting. So let's assume your machine learning model is predicting actually 4 megawatt, but your machine learning model is predicting as a 3 megawatt. It is a 5 megawatt, but your machine learning model predicting as a 7 megawatt. It is a 6 megawatt, but your machine learning model predicting as a 4 megawatt. So this is the predicted value. Generally, we can call it the y hat. And this is the actual value. Generally, we call it as a y. Y is called as the actual value. Y hat is called as a predicted value. Now, how we observe the performance of this linear regression model in terms of the mean absolute error. How we calculate the mean absolute error? What is the error? Anyone can tell based on this discussion what may be the error? How we calculate the error for a first sample? This is a sample 1. For the first sample, I want to calculate the error of the machine learning model. How? Anyone, please? How we calculate the error for a machine learning model, trained machine learning model for the first sample? Anyone please respond. Whether it is the right or wrong, nothing happened. Just if you are active, it will be more interesting for me. So, the name untunante, yes, perfect. Nicholas Byrie. Right. That's the difference between the actual value and your predicted value. Perfect. Your actual value, perfect. So now, so if you want to calculate the error, so error equal to your error equal to actual value y minus your predicted value y hat. But it's not a only error. It will be absolute error. Absolute error means what you have to take? You have to take the modulus. So now it is the absolute error. It is not only absolute error. It is a mean absolute error. Mean absolute error means you have to take the all the samples, add this error for all samples, sample 1 to sample 3 and divided by 3. So this is called as your mean absolute error. I think you agree with all. So mean absolute error. This is error. Y minus y naught is error. And modulus, that is called absolute error. And sum all for all the samples divided by total number of samples. That will give the mean absolute error. So what is the formula for the mean absolute error? So mean absolute error is equal to 1 by n. N is the number of samples. Sigma I equal to 1 to n modulus of y minus y hat. So that is the formula for the mean absolute error. I think you are clear, right? Good. Now, second topic is mean square error. How we calculate the mean square error? So how we calculate the mean square error? Any idea? So name itself says that. First error. How we calculate the error? As you said earlier, So I want to write the mean square error. So first consider the error. So what is the error? What is the error? Difference between the actual value minus predicted value. And square error. That means you have to take the square. And mean. Mean equivalent you have to sum it. Sum it for all the samples divided by number of samples. So that is the how we can calculate the mean square error. Okay. So y minus y hat error square error sum divided by total number of samples, that is the mean square error. Okay. And what happened? And what about the next one? RMSE, root mean square error. Another error is called as the RMSE, root mean square error. The name itself says that MSE already available. MSE equal to 1 by n sigma I equal to 1 to n y minus y hat whole square. What else required? Root. So this is called as a root mean square error. So these are the different errors that are used to analyze the performance of your machine learning model on the regression problem. Okay. And one more thing, one more is called an R square error. And how we calculate the R square, not error, it is the R square score. It's called score. R square score. So how we calculate the R square score? Okay, I will write here. So R square score equal to, we can write like 1 minus actual value minus predicted value whole square divided by actual value minus mean of the actual value whole square. So that's how we can calculate the R square score. It's slightly different and somewhat difficult when compared to the first three. So first three, either it is a mean absolute error or mean square error or root mean square error. It will observe only how much distance for your predicted value from the actual value. Whether you go for the MAE or go for the MSE or go for the RMSE, what it will see how much far your predicted value from the actual value error. But R square score, it also includes the variance of the. It will capture the see sometimes your load C. Let us assume every day on average Sunday in our campus load will be, let us assume load will be around 3 megawatt. Let us assume. Suppose if the Sunday comes under the annual day or sparkle day, then the consumption suddenly rises. So that type of typical situations can be observed based on the R2 square also. So based on this R2 square also, which capture the variance information in the data. So this R square error can also capture that information. That means the sudden disturbances, sudden fluctuations in the loads in the data pattern that can be observed based on the R square score. So these are the different type of metrics that are used in the what's called to solve the regression problem. So I said that. So what is the regression problem? What are the different models are available? And what are the different metrics are available to solve this regression problem? Till now we discussed it. Okay. Now, so we discussed about all the things. So coming to the next topic. So where we can use this type of regression problem, where we can see the regression problems. So load demand prediction, stock price prediction, credit score assessment. So all these comes under the regression problems. Okay. So hope you understand. Now we will move to the another one that is called the classification. So classifications are again two categories, as I said. Thank you, students. Actually, it's already 4 p.m.